This is a sample problem for adding or subtracting with measurements, so using significant figures. Significant figures is the format where the last digit is the estimate. So for example, if we're converting 20.2 degrees Celsius to Kelvin, the way you convert Celsius to Kelvin is to add 273.15. So I'll go ahead and show that addition. But when we do it, we notice that the last digits are the uncertain one. So the 2 is uncertain in the measurement 20.2 degrees Celsius, like the thermometer might have been a little bit off and might be really 0.1 or 0.3. So because the tenths place is uncertain in the measurement, when we add them together, the tenths place is still uncertain in the answer. There's no way to get around that, so that means that this extra digit is useless because this is the estimate. So we're going to round our answers. So the last digit is the estimate, and then it's in significant figures format. So it winds up being 293.4 Kelvin. So the last digit is the estimate. So in adding and subtracting, you just count digits after the decimal. Multiplying and dividing is a little bit different. So when you're multiplying or dividing, because the decimal moves around when you multiply or divide, you need to count significant figures. So for example, what is the density of a substance with a mass of 2,050 grams and a volume of 0.001010 kiloliters? So we have numbers with a lot of zeros in them in this example on purpose because the zeros change which digit is uncertain. Some zeros are just placeholders and some zeros are part of the measurement. So to find density, we're going to divide the mass by the volume. When we do that on our calculator, we get 2029702.97 grams per kiloliter. But probably not all of those digits are actually meaning something. So we need to count significant figures. So in this top number, the 2050, this last 0 is just a placeholder. We could write this 2.05 times 10 to the third. So zeros at the end are placeholders. Zeros in the middle, they always count. So that's going to be 3 significant figures. In this one, zeros before non-zeros are just placeholders. We could write 1.010 times 10 to the negative third. But then all of these zeros count, this middle one and also the end one, because there's a decimal. So if you didn't want that last zero to count, you would have to move the decimal somewhere else. That's going to be 1, 2, 3, 4. So you don't count the first zeros. You do count any zeros after the first non-zero digit if there's a decimal. So we have 3 and 4, and then we're going to round our answer so it has the same number of significant figures as the measurement with the fewest, so that's going to be 3. So we round to 1, 2, 3, and there's a 9 after it, so we're going to round to 203,000.